Hi, I'm Tom Paulson with Limitless Ag Solutions.
And I'm Joey Paulson with Lone Oak Ag. And today we want to demonstrate to you live 3 water conditioning products against an untreated check as they are added to man-made hard water and given time to do their thing. And then at the end we are going to add our 0-20-20 in replace of a herbicide, aka glyphosate, to show exactly how they work in action and how our product, Halo, at the end stays in complete solution. So each bottle represents, we got bottle 4, which is Halo, bottle 3, which is Winfield's Class Act, bottle 2, which is spray grade AMS, and bottle 1, which is an untreated check. So if you'd want to come forward, we'll explain it a little bit more in detail. So as you can see, bottle 1 is our untreated check with 32 ounces of purified water. We then added a 1/4 teaspoon of copper sulfate, and the reason for copper sulfate is it dissolves completely clear in the water solution and has a blue gradient to it that will also show a more clear way of how each product handles the situation once we add the 0-20-20. And then it's 4 milliliters of 0-20-20 at the end of the trial. And then we'll move to bottle 2, which is our spray grade AMS at 3 pounds per acre equivalent. Obviously, again, our 32 ounces of purified water, our 1/4 teaspoon of copper sulfate, and the math works to 1.2 dry ounces of AMS, which was added already so we could let it do its thing, and that's what we need to do with water conditioning products. Let them do their thing first before we add the herbicides. And then again, 4 milliliters of our 0-20-20 at the end. We'll go to bottle 3.
And bottle 3 is, as Joey said, we are using Class Act from Winfield, which is pretty much become an industry standard alongside spray grade AMS for water conditioning products. The same 32 ounces of purified water, the 1/4 teaspoon of copper sulfate again. Our rate equivalent in this jug comes out to be 23 milliliters of Class Act prior to adding our 4 milliliters of 0-20-20. And like Joey said, it's important that we allow these products to effectively blend in with the water before we start adding our phosphorus fertilizer. And finally, number 4, which is our product, Halo, at a 10 ounce per 100 equivalent with the 32 ounces of purified water, the 1/4 teaspoon of copper sulfate. And in this blend, in this bottle, we have 0.8 milliliters of Halo prior to adding our 0-20-20 phosphorus fertilizer. So after explaining that, what we're going to do is we're going to go ahead and show you what happens when we add our phosphorus-based fertilizer to, and the reason we're doing this, the reason we're using 0-20-20, first of all, the 0-20-20 product is a food-grade based fertilizers, meaning that there are no other detectable heavy metals within this product that could be contaminating our experiment. It's in pure form, and the phosphorus in this product will be mimicking a product like Roundup or glyphosate, which is phosphorus based, to show you exactly what would happen in a physical nature when we added these herbicides. So 4 milliliters to the untreated check. As you can see, it instantly starts clouding up. That's the reaction of our copper with our phosphorus.
I'll take and shake these as we go.
Exactly what you don't want to see, which is why these products exist in the first place. Bottle 2, our spray grade AMS, 4 milliliters of 0-20-20.
Again at 3 pounds per acre equivalent.
Number 3, the Class Act. Same mix.
separation again. Class Act at 2.5 gallons per 100 equivalent.
And lastly, our Halo.
At 10 ounces per 100 equivalent.
So as you can see very clearly, the reaction in bottle number 1, the untreated check, which is typical, I mean, that was probably what everybody thought that maybe would happen in this experiment, but the AMS bottle, the Class Act bottle, both started clouding equally the same as our untreated check, which means these products didn't separate or keep separate the phosphorus molecule from the copper molecule binding, which is what we'll see over time. These products will separate out to the bottom just like they do in the untreated check. Now, for our product Halo, everything stays perfectly in solution, which what's causing that is Halo is a strong chelator, meaning this product, even at these really low rates, has the ability to grab a hold of all of the heavy metal material that is in our water that would bind itself to our herbicides, making them less effective. So it gets all that stuff out of the way, allowing the effectiveness to be what we would like to believe is 100% effective from these herbicides that we have put in our spray mixes, or, you know, for that matter, fungicides and insecticides as well, or any other material that we would want to add to a spray solution. We need to keep that investment working for us.
They all need to be kept, no matter what. I mean, that is the #1 goal. And we must remember, we took purified water and only added copper sulfate. I mean, you think of water coming out of your well at your farm, even at the co-op for that matter, it's going to have more minerals than just copper. I mean, we're talking iron, calcium, magnesium, the list goes on. And Halo, it does them all. It doesn't only go to one or the other. It treats the whole.
The biggest culprit that we face is calcium. And when you think of, you know, in particular phosphorus, how phosphorus is mined to create phosphorus fertilizers would be calcium phosphate. And in order to make that phosphorus effective, the calcium has to be removed from the phosphorus. So by the use of sulfuric acid, we can eliminate the calcium off of the phosphorus, thus then makes phosphoric acid, which in a purified form becomes the base product for our 0-20-20. And if these elements ever come back into contact again, they like each other so much that they will form, become insoluble in water, and thus become ineffective.
Correct. Now, Thomas, I think you should share your explanation as to each product and how much we would have to use in quantity across spraying a certain amount of acres.
Yeah, if we were going to spray these rates across, say, 2,500 acres, the amount of AMS that we would need to treat that water for those acres would be 7,500 pounds or 150 bags worth of product. For Class Act, the same acres, 2,500 acres at these rates, it would be 625 gallons worth of material to treat that water. For Halo, the same 2,500 acres is 20 gallons. So if you think about the difference between these treatments, as you're going to see over time, the difference in effectiveness is one thing, but the other thing is it's far less product to do a better job across those acres. If you think about how many, you know, that would be a couple of shuttles plus some 2.5 gallon jugs to make this work, or pallets worth of bags for 4 or 5 gallon pails, you can do the equivalent job.
Correct. And I think another thing to add too is that what we're after here today is purely treating the water.
Correct.
One would argue, you know, that in spraying certain solutions you may need a nitrogen source and or a surfactant like oil. And I would say, and I would argue that I would like to see a product like Halo where we know step number one, water's treated. Then we can add our appropriate surfactants in order to do the job correctly.
Agreed. You know, and we have nitrogen components in both of these products at rates. We can add a nitrogen source to Halo very cost effectively. And as questions come about as to, okay, what is the cost difference per acre of these materials? The price point of this product allows us to be able to add those other materials and still be underneath the competition on price per acre. So we look at price per acre, we look at the amount of volume we're going to have to carry to treat water, and we look at the most important part of it is the effectiveness. As you can clearly see, if we want to take the camera, we can already actually see in these products how the separation is taking place.
Let's start at bottle one, just like we did before. And then we can show. So here's bottle one, again, untreated, check. Move on to bottle two. Spray grade AMS, again at 3 pounds per acre equivalent.
You can see the cloudiness in the bottom half of the jug already taking place, and that will, over time, continue to move its way down. It's easier to see in the Class Act because of the color nature of the product. It has a corn syrup-based material in it, which allows us to see it a little clearly, but right there.
Very distinct line.
Half of that bottle, and the separation has already taken place in here. Clearly we can see that everything in that particular jug has stayed in solution. So with that, what we're going to do here is we're going to allow these products to sit. We're going to snap pictures at timed intervals, maybe 2-3 times after this, and report back, and we will thus then see the vast difference in effectiveness in treating this water.
Correct. I think we got to say thank you. Appreciate it very much, and if there's any questions, please contact either one of us and we would be glad to help.
Thank you.